All right, everybody, welcome to the video here for lesson number 3 on dividing a segment proportionally. So the opening exercise is something that you could totally do by yourself. So I'm going to ask you to graph these 2 points, use your straight edge to connect them, and use your knowledge to figure out where the midpoint of the segment is. So go ahead, pause the video, graph your points, and see what you get. All right, so let's see how you did. So if you graph the point 1, 2, you're here, it's point A, and the point 7, -2, you're here, that's point B. So if you use your straight edge here, you're going to wind up seeing a line that looks something like this. Now, there's a lot of different ways of finding the midpoint. You can kind of guess and check, and I'm sure some of you even did that. You guessed it was right about here, which you'd be right. I'll even label it M for midpoint. Now, how we do this using coordinate geometry is actually using slope. So what I'm hoping that you noticed was to get from A to B, you went down 4 boxes, and you went to the right 3 boxes. So if I want to find the midpoint, I want to cut those numbers in half. So if we cut 4 in half, that would be 2. And if we cut 6 in half, that would be 3. So if I start at A and go down 2 boxes and go over 3 boxes, we're cutting that slope in half. We're locating M. So the coordinate of M is going to be the coordinate of 4, 0. It says here to explain how you arrived at your answer, so you'd be able to say, I cut the slope in half. Now, that's not the only way of doing that. There is a algebraic method of finding the midpoint, and this is actually a typo. This should say 4 here. Actually, I'll do it in black so it looks better. Let's see, black, where are you? There you go. So this should say 4. All right, so when you're finding the midpoint algebraically, what you're doing is you're finding the x-coordinate and y-coordinate separately. And you're just going to take half of the sum of the x values and half of the sum of the y values. That's going to give you the x and y coordinates separately, and you'd be able to put them back together to say that the point is 4, 0. It's basically just addition and multiplication. So let's try a couple using this new method. So if we wanted to find the coordinate of the midpoint of CD, C having the coordinate of 8, 10, and D having the coordinate of -12, +16. If I wanted to find the x-coordinate of the midpoint, I would take half of the sum of 8 plus -12. Well, if I do that, type it in your calculator, you're going to wind up getting a value there of -2. If you do the same thing for the y-coordinate, take half of the sum of the y-coordinates, you would wind up getting 13. So the midpoint is -2, 13. All right, pause the video and try B by yourself. All right, so if you tried B by yourself, to find the x-coordinate of the midpoint, you would take half of -3 plus 11, which is going to give you 4. The y-coordinate of the midpoint is going to be half of 5 plus -14, which is not going to be a nice number. It's going to be a decimal. So you're going to get -4.5. So the midpoint is going to be 4, -4.5. 4.5 is also the fraction 9/2. Either way, it's the same thing. So that's something that you learned in middle school. Literally, probably in 7th grade, you learned how to find midpoints. You might not have done the algebra the same way I'm doing here, but it's the same idea. Okay. Now, the big goal of geometry is not just to be able to cut something in half. That's almost too easy. I want to be able to break it apart into equal-sized segments. For example, I want to be able to take a segment and cut it into 4 pieces or 5 pieces or 6 pieces and find it so that there's a ratio of parts that is consistent with whatever the ratio is that they're looking for. So to do this, we're going to do a very simple process. It's a little bit confusing at first, but once you get it, it's pretty straightforward. So let's take a look at example 2. So example 2 says point Q is on the segment MN such that MQ compared to QN is in a ratio of 2 to 3. Now this ratio tells us something very important. There are going to be 2 parts before Q and 3 parts after Q, meaning in total there are 5 parts. I'm getting that because the ratio is 2 to 3, so there's 2 parts and 3 parts, so in total there's 5 parts. So eventually when I have this segment, I want to chop it up into 5 equal parts. Now on the coordinate plane we can do that, so if I graph the point 0, 3, label that M, and the point 5, negative 7, label that N. This line, which let me grab my straight edge here, this line can be cut into 5 equal sized pieces. Now to do that, I'm going to use slope. So I'm going to say, all right, to get from M to N, I'm going to have to go to the right and down a certain number. I'm going to go to the right 5, and I'm going to go down 10. Notice I'm saying negative 10 because I'm going down 10. So if I want to break this up into 5 pieces, I want to go to the right 1, down 2. If I go to the right 1, down 2, to the right 1, down 2, to the right 1, down 2, and to the right 1, down 2. Notice using a straight edge here is going to be very important. I'm going to wind up finding all of the different coordinates that are separating this into 5 equal pieces. I have 1 piece here, 2, 3, 4, 5 pieces. So I've just divided this segment proportionally into 5 equal parts. Now, if I want to figure out which point is Q, because any of these points realistically could be Q, but I want to pick a Q that's going to separate this into 2 parts versus 3 parts. So Q is actually going to be this point here. Now, this is all great and easy to do. I don't want to say easy to do, but relatively easy to do on the coordinate plane to find out that Q is the point 2, negative 1, because I could just count boxes. Some of the questions that you'll see in today's lesson are not going to be so easy. We might have to actually go through and do this with bigger numbers that we can't graph, or I might not even provide you with graph paper. So there's another way of doing it. So I want to show you the alternate method to see that you get the same exact answer. So I'm going to make a quick table of values here. I don't need that. I'm going to start with the first point that they gave me, point M, 0, 3. And these are the x values and the y values of the point. Now this concept of right 1, down 2 is going to be important here. If I want to move to the right 1, I'm going to add 1 to the x values. If I want to go down 2, I'm going to subtract 2 to the y values. So if I start at the point 0, 3, and I add 1 to the x value, and subtract 1 to the y value, I get the point 1, 1. Notice that's the point here. If I do that again, if I add 1 to 1, I get 2. If I subtract 2 to 1, I get negative 1. And I'm going to keep going with this pattern until I get the point N. So if I add 1 again, I'm at 3. If I subtract 2 again, I'm at negative 3. Notice that's this point here. If I add 1 again, I'm at 4. Subtract 2 again, I got negative 5. Notice that's this point here. If I add 1 again, I'm at 5. Subtract 2 again, I have negative 7. So now I've gotten to the point of M. This is point M. And this is point N. Now I want to separate this so that there are 2 points above and 3 points below whatever the point is I'm looking for. So if I circle the point 2, -1, notice there are 2 pieces here and 3 parts here. So 2, -1 is separating my list of points here into a 2 to 3 ratio like they wanted. So this winds up being point Q. All right, let's try and look at this in a algebraic way. So example 2 can be done algebraically. There's this process that you can use, and you could Google it if you want to and look it up on the internet. And you could just Google algebraically dividing a segment proportionally. I personally don't like it because it's requiring you to remember a lot of things, remember formulas, and look at the ratio a little bit different. Notice I'm using 2/5 instead of 2/3. This is actually how I used to teach it, and I used to have a lot of students get it wrong. Now that I've changed to looking at it as a geometric approach, I actually wind up getting more students that get these questions right. So let's try another one. Example 3. Example 3, notice there's no graph paper here. So we have to kind of visualize where these points are so that we can try and figure out how we can divide this up. So it gives us point A, which is -8, -4, and point B, which is +16, +4. So -8, -4 would be to the left and down, so I'm going to put it over here someplace. And B would be +16, +4, so if I was to graph it, it'd be up here someplace. The location doesn't really matter, but we want to make sure that whatever point's above the other is in the right spot. And I'm just going to connect them, and we're kind of just sketching what we would have seen on graph paper. Now, if point A is a coordinate -8, -4, and point B is the coordinate 16, 4, what I have to do is figure out how much do I have to move to the right or to the left and up or down to get from A to B. So if I start at -8 and I go all the way to +16, how far would that be to the right? That would be 24 boxes to the right. -8 to 0 is 8, and then 16 more would be 24. Looking at the y values, if I start at -4 and I go up to +4, that would be going up 8. Notice both are positive because we're going both in the positive direction. Now this ratio that they're giving us is 3 to 5, meaning there are 8 parts. So if I wanted to separate 24 into 8 even-sized parts, I could do 24 divided by 8, which would be +3. So I'd go up 3, 3, 3, 3, 3. So I'm adding 3 here each time. If I wanted to separate 8 into 8 equal-sized parts, I'd go up 1, up 1, up 1, up 1. So I'd be adding 1 to each part. So essentially I'm moving right 3, up 1. Each time I go to the right 3, up 1, I'd be at a new coordinate or a new point on this line. If I do that enough times, I would break this up into 8 equal-sized parts. Now, the sketch is great, and it helps us understand this piece, the right 3, up 1. But I need to figure out what these coordinates are. So I'm going to make a quick table of values again, just like I did on the last problem. I have an x value column and a y value column. The x values are going to go up by 3. The y values are going to go up by 1. First point I have is -8, -4. So if I add 3 to the x value, I would get -5, -2, 1, 4, and 7. Notice I'm stopping at 7. No, I'm not. I'm going to go 10, 13, 16. My bad. I'm stopping at 16 because that's the coordinate of B. If I go up by 1 in the y column, I'd be at -3, -2, -1, 0, 1, 2, 3, and 4. So notice this first point I labeled was point A. The last point I put in my table was point B. I think by doing the columns separately, it's a little bit easier, so you're not changing the numbers every time. It's hard to do with mental math. So now our job is to figure out what point would divide this list of points into a ratio of 3 to 5. So if I count the number of points that I have, so if I go 1 point, 2 points, 3 points, I circle the next one, then I have 1, 2, 3, 4, 5 points. So here I have 3 points, or 3 parts. And above that point that I circled, whoops, I have 5 parts. I've just made a ratio of 3 to 5. So point P, the point that's in between them, is going to be the coordinate 1, negative 1. Pretty straightforward if you use the table. Let's try another one. So number 4 gives us another ratio here. This ratio is 4 to 5, which would be 9 parts. It gives us the two coordinates 7, 2, and 25, 2. Notice they have the same y value, which means they're going to be on the same horizontal line. So when I sketch this out, I'm going to say point A, which is 7, 2. And somewhere over here is going to be point B, which is 25, 2. So to get from point A to point B, I'm not going to have any vertical change, but I am going to have a horizontal change. So how much do I have to go from 7 to 25? So if I go from 7 to 25, I'm going to the right 18. Now I want to chop that into 9 equal parts. So that means I'm going to go to the right 2, and 2, and 2, and 2. That's going to chop this up into 9 parts. I'm going to go up 0. I'm not having any vertical change. So when I make this table of values, so here's my x column and my y column. The x column is each time going to go up by 2. The y values are going to not change at all. They're all going to be 2. So the first point I'm going to write down is point A, the starting point. And I'm going to add 2 to all these x values until I get to 25. So I'd have 9, 11, 13, 15, 17, 19, 21, 23, and then finally 25. Because of the 0, all of these are 2. They're all going to be on that same line. Then I want to chop this up so that I have 4 pieces compared to 5 pieces. So if I go 1, 2, 3, 4 points, circle the next one. This has 4 parts. The bottom, notice, is 5 points, so that would be 5 parts. So the coordinate of P that they're looking for is 15, 2. If you don't like this method and you'd rather have something that's a equation, again, like I said before, Google algebraically dividing a segment proportionally. Videos will pop up, or email me. I'll even find it for you and send it to you. I personally think it's harder. I think the method I'm showing you in this video is a lot easier. So at this point, I'm going to have you pause the video or come back to the video, try your homework separately and see how you do, and then see if you're getting these answers the same way that I am. So go ahead, pause your video, try your homework. All right, welcome back to the video. So hopefully you tried these questions on your own and you're just checking answers at this point. If you were confused and you just wanted to watch some more, you can do that too. But this is really the point of the lesson where you'd be trying questions on your own. So let's take a look. So this first question gives us a ratio of 2 to 1. So that would be 3 parts. It gives us a coordinate of x, which is 2, 8. And a coordinate of y, which is 5, 2. Use your straight edge and connect those up. Now our job here is to figure out, how do I get from x to y? So if I go to the right 3, down 6. Notice I went down, so I made it negative. Now, if I want to chop this up into 3 parts, I want to chop, I want to chop 3 into parts of 1 and -6 into parts of 2. So if I go to the right one, down 2, to the right one, down 2, I'm chopping this up so that I now have 3 different pieces of my segment. So I'm going to the right 1, down 2. Now the coordinate that they're looking for here, coordinate A, is going to be where I have 2 pieces compared to 1. So that would be this point here. This is coordinate A. So coordinate A is the coordinate 4, 4. Just because this is a learning experience, I want to show you again how I did this with my table. So if I have a table of values here for x and y, the x values are going to go up by 1, down by 2. The first x value is 2, 8. So if I make my x values go up by 1, I'd be at 3, then 4, then 5. I would stop there because y has an x coordinate of 5. The y coordinates are going to go down by 2, so subtract 2. So now I have point x and I have point y. The point that would separate this into a 2-part to 1-part ratio would be the coordinate 4, 4. So again, we'd still get that answer of 4, 4. If you like the graph, do it on a graph paper. If you like it with the table, do it with the table. There are, however, questions where the graph paper really won't be helpful, like number 2. Notice there's no graph paper here. So since there's no graph paper here, we kind of have to either make a sketch or just start by making our table, either way. So I like the sketch because it kind of helps me visualize what I'm doing here. So point R is -4, +9. So we'll put R over here, -4, +9. And then W somewhere over here. W is above that because it's 24. That's way above number 9. So that would be 6, 24. So now we have to think, how do I get from R to W? I'm going to go to the right, and I'm going to go up. I'm going to go to the right 10, and I'm going to go up 15. -4 to +6 is a difference of 10. 9 to 24, that's a difference of 15. So now let's look at my ratio. My ratio is telling us I want to make 5 parts. So if I have 10 and I want to separate that into 5 equal parts, I'm going to go to the right 2. If I have 15 and I want to make that into 5 equal parts, I'm going to go up 3. So if I go to the right 2, up 3, to the right 2, up 3, I'm going to separate this out into 5 equal parts. Now, to do this with my table, I'm going to start with my x and y coordinates. The first x value and y value I have is -4, 9. And I'm going to add 2 to all my x values and add 3 to all my y values. All right, that's what I'm adding to each one. So if I add 2, I'd have -2, 0, 2, 4, 6. I'm going to stop at 6 because that's the x coordinate I want to stop at. If I add 3 to my 9 value, I'm going to have 12, 15, 18, 21, 24. So again, I have point R, and I know point W. I want to pick the point on this list that would separate this into 2 parts versus 3 parts. That would be this point 0, 15. That would make this 2 pieces compared to 3 pieces. So the point they're looking for, point P, is 0, 15. That's my answer. Hopefully you got that on your own. Number 3 is asking us to find a midpoint. As soon as I see the word midpoint, I'm not thinking about graphing. I'm not thinking about sketching. I'm just thinking about the first thing we did in the lesson, which was my simple equation. The simple equation is the x value of the midpoint is half of the sum of the x values. So the x value of this midpoint is -1. The y value of this midpoint is half of the sum of the y values. So that'll be 8 plus -10, which would also be -1. So the midpoint is -1, -1. Midpoint is one of those things that's going to come up a lot towards the end of this chapter. So knowing how to do it algebraically and quickly using algebra is going to be an important tool for us to use. Not having to make a sketch and dividing everything by 2 is just going to make everything easier for us. So this process is going to be important. So we want to be able to do that using algebra. Hopefully this video helped. Hopefully I see you soon and we can keep going here with this unit. Okay, make sure you're watching your videos and keep track of your homework. See you soon.